From the Howard Hughes Medical Institute, the 2011 Holiday Lectures on Science. This year's lectures, Bones, Stones, and Genes, the Origin of Modern Humans, will be given by Dr. John Shea, Professor of Anthropology at Stony Brook University, Dr. Sarah Tishkoff, Professor of Genetics and Biology at the University of Pennsylvania, and Dr. Tim White, Professor of Integrative Biology at the University of California, Berkeley. The third lecture is titled Stone Tools and the Evolution of Human Behavior. And now, a brief video to introduce our lecturer, Dr. John Shea.
How do we find these stone tools and fossilized bones? It's not a secret. We go to different parts of the world where there's active erosion going on, where ancient sediments have been lifted up and now they're being eroded. These kinds of sediments form near water. Ancient humans needed water, ancient humans needed food. So we look in those exposed sediments to see if we can find fossil animal bones and stone tools. Now, how do you know these things are tools and not just naturally fractured rock? Well, to determine that, we need to see how humans break stones and how the consequences of humans breaking stones purposefully differs from how nature breaks stones. There's some overlap, and so we have to look carefully in geological deposits where there's not enough energy involved in the formation of that deposit to fracture stone in the same forceful kind of ways that humans broke stones in antiquity. So our signal of human early stone tool use really has to be picked out of a background noise of natural damage that occurs on stone as a consequence of geology. As an archaeologist, I guess for me the really satisfying thing about it is I get to help young people get excited about these same sorts of subjects, about opening their eyes to how a knowledge about the natural world can lead them to a career in science or lead them to a greater appreciation of the humanities. And the most effective cases where I've succeeded as an educator, I think, are those in which I've taken students out of the classroom, out of the university, off into the field in the Middle East or off into the field in Africa, and had them confront other cultures, had them actually excavate the archaeological sites, find the remains, see what we do. But I'll never forget the words of one of my students who were coming back from Ethiopia. We'd had cattle raids, we'd had brush fires, we put the car to a river and all kinds. You name the disaster we'd had that season. We got back to the capital of Ethiopia, and my student came up and said, "Professor Shea, that was the adventure of a lifetime. Let's do it again next year." Thank you. Thank you. Because I'm an archaeologist, people often bring me things like this stone tool. This is actual size there for scale here. And they ask me about it. How old is it? Who made it? What was it used for? How was it used? Now, the first thing I say back to them when they ask me a question like that is, where did you find it? What was the context in which it was found? Now, context refers to the place where the artifact was found and the associations between artifacts and other things in the same sediments. Animal bones, other stone tools, other sorts of remains. Much of what archaeologists can say about past human behavior depends on knowing about context, which things were found together and which things were found apart. Without this information, all I can tell you is that this is a stone tool. But because I know this artifact was found at a particular site, the BNS locality in the lower Omo Valley in Ethiopia, I can tell you it was made about 104,000 years ago by early Homo sapiens, and it was probably used as a knife or a spear point. Archaeology is a fun and exciting field. My profession does not have an image problem. The popular image, though, of archaeologists emphasizes adventure, and archaeology can indeed be the adventure of a lifetime. I've been doing it for more than 30 years, and I've never had a dull moment. But behind all the thrilling adventures and the interesting ideas are facts. Archaeology is a search for facts and evidence for human behavior. Archaeologists take notes, measure things, and publish our findings so that our colleagues can judge our efforts, evaluate our results, and use the things we've found in their own research. That helps them ask new research questions. This, for example, is a slide from a lecture I gave at a scientific conference, and the particular contents aren't really that important. It's simply showing you the relative frequencies of different kinds of stone tools from several sites in southern Ethiopia that we excavated. That's just to make the point. It's not just about pictures of pretty objects, it's about the quantification of these objects and their communication to other scholars. Now, archaeology is a part of anthropology, the study of human behavior in evolutionary and cross-cultural perspectives. Archaeologists work with cultural anthropologists and physical anthropologists, but archaeology has links to many other fields, such as history, linguistics, geology, art history, and other scientific endeavors. Archaeology's big questions are anthropology's big questions. How are we different from other species, and how do humans differ from each other? Now, people often confuse archaeology and anthropology. The words are similar, and many archaeologists, like myself, work in anthropology departments. Archaeology is the study of residues, using the scientific method to reconstruct human behavior. Residues are any tangible product of human behavior, a moved natural object or an artifact, a change in sediments, anything that's the result of human actions. Residues are everything from the contents of your town landfill to the exhibits in an art museum. Now, this is a picture of an archaeological site in Egypt. You can see the outlines of some of the buildings and perhaps some of the outlines of the streets. These buildings and streets are residues, but so too are the fragments of pottery, the nails, the bronze cutting tools, and other things that we've excavated from this site. So too are the plant remains and animal bones. These are all residues of human behavior. So what kinds of behavior are we interested in as archaeologists? Well, everything, really. We're interested in settlement patterns, where people lived. We're interested in technology, how people made tools, how they used them. We're interested in subsistence and diet, and what people ate. We're interested in social organization, how people organize themselves into effective groups, or not. And we're also interested in ideology, and what people thought, and what they believed. But mostly, though, we're interested in variability. We're interested in finding out why people do different things under similar circumstances. Among the behavior sciences, archaeology has a unique long-term perspective. Historical records only go back about 5,000 years at best, yet the oldest archaeological sites we know of are more than 2 million years old. What is an archaeological site? Well, I tell my students it's whatever they let you dig, but the more specific definition of it is a site is any place where archaeologists have found preserved residues of human behavior. In recent periods, when people lived in the same place for long periods of time, they've deposited vast quantities of residues in the same place, such as this cliff dwelling from the American Southwest or this mound near the town of Jericho in the Near East. But for most of human prehistory, people moved around a lot. They voted with their feet, in other words, and their sites can be very difficult to find, and once found, very hard to date, hard to estimate their ages. So that's a question we'll turn to now. How do we know how old something is? Well, whether a site has one level or hundreds of levels, making sense of them requires one to estimate how old these deposits are. Archaeologists estimate the age of residue deposits using basic stratigraphic principles from geology and a variety of geophysical dating techniques. We'll cover the basic principles first here just by definition, and then I'll give you an example of some of these things in action. The first of these principles is the principle of superposition. Now, the principle of superposition holds that in an undisturbed sequence of deposits, the older deposits are more deeply buried, and the younger deposits are more shallowly buried, younger towards the top. The second principle is the principle of association. The principle of association holds that objects enclosed within the same sediment were deposited at the same time. Now, these are nice principles, but let me give you a demonstration of this. Okay. Imagine, if you will, that this is a deposit of sediments, and this little ant farm-like deposit is an ancient landscape. A landscape populated by prehistoric humans. And this guy's just going to hunt a rhino with a spear. You know what happens when that occurs? This guy dies. Okay? The rhino goes along for 10 more years, he dies. An elephant comes along. Another idiot decides to take on the mammoth with no tools in his hands. He's dead. Eventually the mammoth runs out of gas. He's dead too. Saber-toothed tiger comes in here, looks for nothing, no dead humans, no carcasses. 15 years later, he buys the farm. Now, a volcano erupts, covers these deposits with ash. There we go. And another civilization arises, a civilization populated by the people of the Hello Kitty tribe. They're bopping along and fighting, and they do the head bonking contest and double elimination. Their pet gorilla wanders by. Oh, what happened to Hello Kitty people? Oh, 10 years later, oh, I'm out of food, no more bananas. There you go. And they're succeeded by a population of robots. All over the space of another century or so. And then another volcano erupts, covering the place with black ash. All right. Now, pretty simple, pretty straightforward. We're archaeologists, we keep things simple. What we have here is the principle of superposition and the principle of association. The older deposits are lower in the sequence, the younger ones are higher up. The objects that were deposited at the same time are enclosed within the same sediment. Now, when I say at the same time, I don't mean at exactly the same time. Here's the little weasel words. When in geology, when we say deposited at the same time, meaning they're enclosed in the same sediments, that means they were deposited by the same geological event, the same depositional event. Some of those individuals could have died days, months, years, decades, even centuries apart. So at the same time is a very fungible concept, and part of your job as an archaeologist is to figure out how much time is represented in that deposit. Now, to answer that kind of question, we usually turn to a series of geophysical techniques, and there are many of them, so I'm just going to focus on the most essential two. Radiocarbon dating is the mainstay of archaeological chronology in recent time periods. In radiocarbon dating, one dates parts of formerly living organisms by measuring the ratios of unstable carbon-14 to stable carbon-12. When cosmic radiation hits nitrogen-14 in the upper atmosphere, it creates an unstable isotope, carbon-14. Carbon-14 decays back into nitrogen-14 at a steady rate or half-life of about 50% per 5,730 years. Carbon-14 settles to Earth and is absorbed and excreted by plants and animals. You're absorbing and excreting carbon-14 right now. In most living plant and animal tissues, the concentration of carbon-14 approximates that in the atmosphere. While they're alive, plants and animals are constantly absorbing and excreting radiocarbon. When plants and animals die, they no longer absorb carbon-14. The carbon-14 in their tissues continues to decay into nitrogen-14. So slowly, the ratio of carbon-12 to carbon-14 increases. Now, knowing the half-life of carbon-14, 5,730 years, we can estimate how much time has passed since a plant or animal died by measuring the amount of carbon-14 to carbon-12 in a sample of wood or bone or charcoal. Radiocarbon dating is effective on samples going back to about 40,000 years ago. Beyond that point, there's so little radioactive carbon left in the sample, it's very difficult to obtain a date. To date the oldest archaeological contexts, we use radiopotassium dating. Radiopotassium dates volcanic rocks by measuring ratios of the isotopes of potassium and argon. The unstable isotope, potassium-40, is produced in the formation of volcanic rocks, and it slowly decays into a stable isotope of argon-40. The half-life for potassium-40 is 1.3 billion years, which means the rocks must be more than 100,000 years old or thereabouts before enough potassium-40 has decayed for it to be measured. So there's a younger age limit on the radiopotassium dating technique. Fossils and archaeological remains are rarely preserved in volcanic rocks. So the application of radiopotassium dating is usually to bracket a sample that contains fossils or archaeological remains. So if you read of a fossil discovery dating to 1.7 million years ago or thereabouts, what that usually means is that archaeologists and geologists have obtained dates from above that deposit and below that deposit, split the difference, and made an estimate of its age accordingly. So putting all this together, we use radiocarbon dating To date the more recent phases of human evolution, those younger than 40,000 years, we use radiopotassium to date the oldest archaeological contexts, so those older than 100,000 years, and to fill the gap between them, we rely on a variety of other techniques, such as thermoluminescence, electron spin resonance, or uranium series dating. To explain the things we find after we've dated them, archaeologists rely on a philosophical principle called uniformitarianism. Uniformitarianism argues that we have to explain the past in terms of the processes we can observe at work in the world around us today. So the present is our guide to the past. Now, uniformitarianism works best with physical and geological and biological processes. Well, for example, when we find clay deposits, as we did at the archaeological site of Ubudiyya in Israel, we infer that those deposits were laid down during a time when the lake covered that site, because nowadays you find similar such clay deposits at the bottom of lakes, like the Sea of Galilee, which is nearby Ubudiyya. Uniformitarianism also works pretty well for residues whose variation is constrained by physical or mechanical or biological factors, by which I mean behaviors such as settlement or subsistence and technology. For example, we can tell the pot on the left-hand side here was not thrown on a wheel like the pot on the right-hand side, because we've studied pots that have been thrown on a wheel, and there are diagnostic traces on pottery that indicate that mode of production. This pot lacks them, so we infer it was made by some other method. Now, things get a little squirrely with uniformitarianism when we start talking about social organization and ideology, because there are so few rules that govern these aspects of human behavior. Say we find a Neanderthal skeleton in a shallow pit, like the one at the right there. Is this a deliberate burial like those we're familiar from recent time periods? Or is it something else? Is it a natural death that was swiftly buried in the cave? Or was it an attempt to conceal homicide? Uniformitarianism can also help us know when it will be impossible to know something. Knowing when you can't know something is vitally important for scientists as well. One example involves the meaning of prehistoric symbols. Now, on the left is the state flag of New Mexico. Because it's an historic artifact, we know what it means. It combines a sun symbol of the Zia Pueblo with the colors of the Cross of Burgundy, a flag that was carried to New Mexico by the conquistadors. On the right is a 17,000-year-old painting of a wild bull from Lascaux Cave in France. Because the people who painted Lascaux Cave left no record of their beliefs, of what they thought this symbol meant, we can't test hypotheses about it. We can argue, we can speculate, but we can't ever winnow down the range of those speculations. The meaning of this symbol is not something we can test objectively and scientifically. People also ask me as an archaeologist, how do you know where to dig? Well, archaeological research begins with a question, usually a bunch of questions, and that question, or those questions, determine where you choose to excavate. Or if you excavate at all. Some archaeological questions can simply be answered by data we already have at hand. In the Omo Kibish project in Ethiopia, our research questions had several parts. Early human fossils had been found in Omo Kibish in the late 1960s, but there are many uncertainties about their age and context. Now, Omo 1 and Omo 2 might look superficially very similar to one another, but physical anthropologists consider them rather strikingly different. We were curious to know if they were indeed of the same age. We also were curious to know about their behavior. Where did they live? What did they eat? What were the tools they made like? What were they doing there in the lower Omo Valley? Answering these research questions required us to travel to one of the most remote parts of Ethiopia and to locate the original fossil sites. And as you guys can see, just like any public works project here, there's 8 guys standing around, 1 person using the shovel. We knew we'd found one of the original sites, this one here at KHS, because in the course of excavating, we recovered a piece of bone that fit back together to one of the fossils that had been recovered by the excavations in 1967. It doesn't get much better than that. We also conducted surveys and found and excavated several new sites. One of the things you never see Lara Croft or Indiana Jones is doing is this kind of work, the cataloging your finds and recording of the information from excavation. The archaeologist's most important tool isn't a gun, it isn't a whip, it's a notebook. While we were running around looking for fossils and excavating archaeological sites, our geologist colleagues collected samples of volcanic rocks for radiopotassium dating and bones for radiocarbon dating. As a result of their work, we were able to establish that the Omo fossils, both 1 and 2, came from member 1 of the Kibbush Formation, dating to about 195,000 years ago. This makes them the oldest known Homo sapiens fossils. We also found other archaeological sites in member 3 dating to around 104,000 years ago, and sites in member 4 dating to between 6,000 and 8,000 years ago. One of the important questions you ask at the conclusion of any research project is, what's next? Well, excavating Omo Kibbush was a lot of fun. And the students in this picture did indeed call it the adventure of a lifetime. More importantly, though, we recovered the facts we needed to answer our major research questions and to ask new ones. Now, one of the really interesting ones is how do the sites from Omo Kibbush relate to sites that Dr. White and his colleagues have excavated in the Middle Awash? Another archaeologist who's looked at the stone tools from both sites has said that these guys looked like they were talking to each other based on the similarities of the stone tools. Now, the sites do date several tens of thousands of years apart, so that'd be a pretty remarkable achievement if they were actually talking to one another. But the similarities are intriguing, that there are such similarities between sites associated with the oldest Homo sapiens fossils in Africa. Now, much of the research in the next step of evaluating our work at Kibbush involves stone tools, and so that's a subject I'm going to turn to next. Tools are important in making humans different from other animals. There are no known groups of humans, nor even individual humans, who can survive long without recourse to tools. Stone tools are the most durable archaeological residues. They are virtually indestructible. The components of modern electronic devices, in comparison, the things you guys have been asked kindly to turn off, those things will probably only survive a few 100,000 years at most, and under the most favorable of conditions. They won't survive as long if you run them over with a car like that. The oldest stone tools, in comparison, date to more than 2.6 million years ago. Few people make and use stone tools any longer, and those of us who do are called flint knappers. Now, making different kinds of stone tools, as you see me doing here, and using them, can suggest hypotheses about how and why prehistoric people made and used tools of one shape or one kind or another under different contexts. And in a way, this is kind of like reverse engineering the simplest technologies. Now, to show you what I've been talking about with stone tool technology, and to give you a bit of a preview of what some of you will be doing this afternoon, the folks here at Howard Hughes have assembled a little film that I'll play next and then narrate over to give you some picture of what's going on here. It's not all intuitively obvious, but it's not rocket science either. Like most flint knappers, I've got a kit with my basic equipment. I'm protecting my leg. And I've got a piece of volcanic rock. I'm striking it with a hammerstone. And it's a swift blow with a flick of the wrist, and there you go. Large, sharp flake. I've set that aside for use later. And I'm showing how to sharpen the edge or chip the edge into a particular shape.
Do that on this edge.
Having struck the flake off the core, now I'm resharpening the edge a bit.
There you have it. You got a sharp tip here. It's a little thick for an arrowhead. Might be better as a knife or a spear point.
Well, this is a piece that might be useful for a knife or spear point, more or less similar in size and shape to the object I showed you at the beginning of the lecture. These things are razor sharp. In fact, I can shave the hair off my arm.
Don't try this at home.
Listen to this guy. You can teach this stuff fairly quickly, and every year at Stony Brook I teach my students how to make stone tools so that they can then take those stone tools and butcher a goat and then barbecue it. So, a lot of fun. It's all fun until somebody loses a thumb. So be careful this afternoon.
Pay attention to you guys who are archaeology students. Look how little time we're taking in hand. Does it feel comfortable?
We also, you'll see, put a tarpaulin down so we don't get our stone tools mixed up with a genuine archaeological record at this site.
It's okay. You start butchering this thing and you're...
We've learned some interesting lessons from these flint knapping experiments. I'm going to focus on 4 that seem to be convergent among many different studies. The first of these is that stone tools are really easy and simple to make. This is not difficult. Secondly, pay attention, this one, the edges are sharp, often sharper than a surgeon's scalpel. Thirdly, children as young as 5 can make simple stone tools. And if you think about it, where do children learn? They learn by imitating their parents. Well, where would they be likely to be imitating their parents? At a habitation site. So when we archaeologists excavate a habitation site, we ought to assume that a certain fraction of those stone tools were probably made by the children. That's an insight that is catching on a bit amongst my profession. Another one that's often in the literature is, oh, there's big differences between men and women, how they make stone tools. There are no differences in the abilities of men and women to make stone tools. Lastly, all of the ways of making stone tools that were in use in antiquity, we think we can reproduce. Archaeologists don't believe there's any lost way of making stone tools. Now, that doesn't mean that's necessarily true. It means that we have, on the basis of our experiments, been able to successfully reverse engineer just about every kind of stone tool we found. So that's some of the knowledge with which we approach the archaeological record. These are some insights from flint knapping experiments. Stone tools are important for human origins research because they are so well preserved. Properly studied, they allow us to compare behavioral residues from the widest range of possible contexts. Pretty much every place people made stone tools, those stone tools are still there unless those contexts have eroded. Now, whether or not those stone tools were important, or what variability there was in the degree of their importance at different points in prehistory, that's a different kind of question. A question I'll be happy to answer if anyone has any questions about it. Yes, here.
I saw that you had pictures of different shapes of arrowheads. Do you see a certain pattern in how they evolved over time? Or, you know, did they constantly get larger? Did they constantly get thinner?
In general, there's a lot of variability. In some regions, there are trends towards smaller tools, others trends towards larger tools. What we try to do when we study the stone tools is to link those trends to models of behavioral variability from what we've seen today. I mean, in many consumer electronics, there's a consistent trend towards smaller devices. And in many areas of stone tool technology, there's a similar such trend towards miniaturization in recent time periods. You know, whether or not they spring from the same sources, that's a different kind of question. But there are some long-term patterns we can see. One such pattern is that over time, the techniques people have used to modify stone tools tend to recover more cutting edge per unit mass of stone than earlier techniques. But there's a trade-off. The techniques people use in more recent time periods also cost more time and require more skill. So there are trends, but there's no global trends. There's lots of recursions and reversals of trends. Another question. Yes, in blue.
I was just wondering, what do you think is like the thing that excites you the most about finding? Like, is it a specific type of tool, or, and if there was a specific thing, where did you find it?
The coolest stone tool I ever found, it probably would be the first one I found. I was walking a path near my parents' house in Massachusetts, and I'd been looking for stone tools for years. There's nothing out there, and then I picked this thing up. It was an ads, an extremely rare kind of ground stone tool, about which more later. And you almost never find these things. And this thing was just sitting there in the middle of the path. I'd walked back and forth, I don't know, 1,000 times previously. So finding something unexpected like that ads I found near my parents' house was probably the coolest thing I ever found. I'll ask for questions a bit later on, but I have to resume the lecture. Okay, we're going to turn now to the archaeology of human evolution, or as we call it, prehistory. Now, we're going to do three things in this lecture. First, we're going to introduce the comparative approach to prehistory, accounting for the time before historical records. Next, we're going to examine evidence for human and earlier hominin behavior from different time periods. And finally, we're going to consider how to explain the behavioral variability we see in the prehistoric archaeological record. Now, first off, a bit of term clarification. Prehistory is what archaeologists call our theories about what happened in the remote past, in the time before historical records. There are two different ways to do prehistory. There's a narrative approach and a comparative approach. In a narrative approach, what you're looking for are changes through time. In a comparative approach, what you're looking for are simply differences between samples from different time periods. That sounds similar, but the difference is that in narrative prehistory, you have to make assumptions about cause and effect. Earlier things cause later things. In a comparative approach, you don't need to make those assumptions. You're simply looking for differences. In this lecture, we're going to follow a comparative approach because it helps us identify crucial gaps in the archaeological record better than a narrative approach does, at least in my opinion. And since it's my lecture, that's what we're going to do. Now, we're going to look at 4 snapshots or moments in prehistory, starting 5,000 years ago and moving backwards in time to 30,000 years ago, 500,000 years ago, and then finally 2 million years ago. As we do this, we're going to look specifically at changes in stone tool technology and in the evidence for what we call complex behavior. First, though, we have to establish some terminology. Archaeologists have been studying stone tools a long time, and some of this terminology will be unfamiliar to those of you who haven't taken a college-level class in archaeology. First off, archaeologists classify stone tools in terms of 6 different modes or ways of making tools. The simplest of these, mode 1, is what we call pebble core technology. Now, a pebble core is just a round rock off of which someone's taken a hammer and split off a few flakes, much like you saw in the demonstration. It's really simple. You guys will be making pebble cores or their near equivalent this afternoon. Mode 2 tech tools are these sorts of things, these large cutting tools. And if you think about it, they're really kind of stretched or expanded or scaled up versions of the pebble cores. They're there to pebble cores what SUVs are to reasonably sized cars. Think of this as the Hummer. The Hummer of hand axes. Mode 3 tools are tools split off from a larger object or a core. They're relatively large flakes. These are broad and thin and flat pieces with a very sharp cutting edge. And we're not going to teach you to do this today because if you make these things, you're likely to lop off the tip of your finger like I very nearly did some while ago. Mode 4, or prismatic blades, are long and thin and narrow, and they stand in relation to mode 3, kind of like if you took this, if this flake or this object were made of rubber and you stretched it to get the maximum amount of cutting edge. This is what you would have with mode 4, prismatic blades. It's a stretched version of these shorter and thinner objects. Mode 5, this is the miniaturization of which I spoke. Mode 5 tools, or geometric microliths, are tiny versions of the large blades. They're scaled down. Now, scaling down like this has a big benefit. If you make a small object like this and keep everything else constant, you end up with a lot more cutting edge by making tools this way than you do by making tools this way. I can carry dozens and dozens and dozens of these little geometric microliths here in my pocket at very little cost to transport at all. In fact, this one was embedded in a suitcase I took around the world several different times until it fell out in the middle of a security checkpoint. That was an entertaining afternoon. These geometric microliths, you can imagine, you can't really do very much with an object like this. You know, go poke a rhinoceros with this, and next thing you know, you're in low Earth orbit. What people would do with these things, geometric microliths, is they would glue them to the sides and tips of bits of bone or wood, in this case, to make complex tools that have multiple parts. You embed it with glue, and something like this would be the tip of an arrow or a spear, such that when this hit an animal, it would cause a large wound that would bleed out really quickly and kill the animal fast. Yeah. Now, the last of these, mode 6, these are ground stone tools. These are tools whose edges have been shaped by abrasion, so they're very smooth and sharp, and as a consequence, when you cut things with them, there's very little friction, and the edge cuts very, very effectively. So this is a basic grammar of stone tools, or at least a typology of stone tools, so that you know what I'm talking about when I show you some of these images. Now let's turn to another important aspect of the archaeological record that we'll be looking at. Okay? Stone tools only tell you part of prehistory. Complexity is an important dimension of prehistoric behavior too. And by complexity, I mean activities that involve bringing together groups of people to act in a coordinated fashion, or bringing together categorically different kinds of materials to achieve a different effect than any of those materials would have achieved by themselves. Some of the categories of complex behavior that we look for in the archaeological record are hearths, or evidence for the controlled use of fire, art and symbolic artifacts, things that transmit a message that's encoded in the material culture. Hafted stone tools, that's archaeologies for a stone tool attached to a handle, more or less like the mode 6 and mode 5 tools are. Collecting small animal prey, that doesn't sound very complex, but how many of you guys ever tried to catch a rabbit? Okay? Yeah, you know what I mean. You use a net. You know, often catching small animals in large quantities involves nets and traps and other devices like this that are themselves things that take you a long, long time and that require you to put together different kinds of materials, wood, fibers, nets, and this sort of thing. Projectile weaponry is another complex aspect of behavior, particularly weapons that have a propulsion component that you don't throw, like a hooked stick or spear thrower or a bow and arrow system. Watercraft, these are complex objects. You can't just jump on a log and colonize Australia. You know, you'd be eaten by saltwater crocodiles like that. So watercraft that can go across large rivers, lakes, and oceans. It's considered to be a complex behavior by implication. Substantial architecture. Now, by that I mean architecture that will withstand the elements. Architecture that will leave an archaeological trace behind. So houses, buildings, these sorts of things. And by ceramics, I simply mean pottery. Clay that's been transformed by fire into a new material. That's a fairly complex process. Have any of you guys ever tried to make pottery in your classes? Yeah, it takes a lot of time, doesn't it? Well, lastly, domesticated plants and animals. Now, by domesticated, I mean these are species for whom humans have taken over their reproductive strategies and altered natural selection so that these creatures are now breeding in a way that serves our advantages, in ways that make it easy for us to control them or easy for us to collect them and consume them. All these complex behaviors I've listed here are uniquely associated with living humans and not with any other living species of primate. So we're looking for derived features, things that are unique to us when we're looking for complex behavior. So let's go back 5,000 years ago. In this, our first snapshot, things look well different from today. There are no metal tools, there's no writing, no cities. Sounds fine to me. But the world of 5,000 years is not unrecognizable. They're familiar things. The largest sites are villages, or a few hundred people, located near sources of fresh water, rivers and streams. The larger settlements subsist on domesticated plants and animals, or wheat, barley, rice in terms of plants, and sheep, goat, cattle, pigs, this sort of thing in the case of the animals. But in most parts of the world 5,000 years ago, people were still hunters and gatherers. They were subsisting on wild foods. Stone tools vary from region to region, but at a global scale, all of modes 1 through 6 are in use at one point or another. Farmers and even some hunter-gatherers use seed grinding equipment, heavy rocks to abrade cereal grasses to make flour and thereon to make bread. And there's evidence for complex visual arts, sculpture, painting, engravings, personal adornments, beads, and these sorts of things. One of the important features you'd notice, though, if you looked about more broadly at 5,000 years ago, is that there are no isolated societies. Groups are linked to one another by complex networks of trade and exchange and kinship and culture. You'll find the same idiosyncratic designs of stone tools across broad regions, indicating that people are in touch with one another across those regions. So let's go back 30,000 years ago. Well, at 30,000 years ago, the world looks very different from 5,000 years ago. But most of the differences simply reflect economics. All humans living 30,000 years ago are hunter-gatherers. There are neither domesticated plants nor domesticated animals. The largest sites from this period are small seasonal camps of a few dozen people. If you were living in them, you'd live with the same 25 or so people for most of your life. There's little evidence for substantial architecture. This is because people move around a lot. When there's a problem in this place, like no food or hostile neighbors, they vote with their feet and move. The stone tools in use 30,000 years ago don't differ at all that very much from those 5,000 years ago. The evidence for mode 6 tools, the edge ground tools, is relatively rare. People made grinding stones much as they did 5,000 years ago, but they used them more for grinding up mineral pigments, for making colored pigments to decorate themselves and decorate their possessions, rather than for grinding up cereal grains to make bread. There is painting and sculpture and other evidence for the visual arts. There's evidence for music and other similar sorts of institutions. And we also see similar kinds of cultural connections, similar tool designs, similar architecture forms, similar kinds of art across broad regions. Now, you might not want to live in the world of 30,000 years ago for a very long time, but properly trained, you could do it. Let's go back 500,000 years ago. 500,000 years ago, things look really different from 30,000 years ago. There are no humans around, only earlier hominins such as Homo heidelbergensis or Homo erectus. Sites from this period, archaeological sites from this period, lack evidence for architecture, and traces of fire are really quite rare. Many sites show evidence for carnivore activity, and this suggests hominins were competing with wolves, lions, leopards, and similar sorts of creatures for access to animal carcasses or for control of protected habitation sites like caves. There's little evidence for the systematic gathering of small mammals, fish, birds, and these sorts of things. And that makes a certain amount of sense. Small groups of people tend to focus on big animal prey. Stone tools found around 500,000 years ago include those of modes 1 through 3, pebble cores, the large cutting tools, and the prepared cores. These are all relatively heavy tools. They probably weren't carried very far from the places where they were made. Probably moved only tens of kilometers or not much more than that. One of the biggest contrasts we see in the record of 500,000 years ago and more recent periods is that there's no evidence for art, for symbols, for music. These things that are so universal among living humans and so universal in the archaeological record of recent times. There's no trace of this. Nor do we see evidence for long-distance trade or cultural links across wide regions. If you chose to stay here, your life, as Hobbes put it, would be solitary, nasty, brutish, and short. Let's go back even further. 2 million years ago, we're looking at an utterly alien landscape. Now, most of the sites from this time period are in Africa, so it might superficially look like an African game park or nature preserve. But there are big differences, even with the world of 500,000 years ago. Hominin fossils from this time period include early Homo, Australopithecus, and Paranthropus, creatures very different from any living primate. Most sites are merely aggregations of stone tools and animal bones near the banks of rivers and lakes, or less often in caves. There's no evidence for the controlled use of fire and no evidence for architecture. Imagine camping out in this environment. The only stone tools we find are mode 1 pebble cores and flakes, little chips struck off of the cores. Now, cut marks on animal bones indicate that some of these tools were used for butchering large mammal carcasses. Now, but we don't know whether these are carcasses that the hominins killed themselves or carcasses that were obtained by scavenging from the kills of carnivores. Carnivore remains are often found together with hominin remains at these sites, and this suggests that humans were often prey for these large cats and canids that were roaming the same landscape. Very few among us would survive more than a day or two in this environment of our evolutionary origin. Even with survival training, based on statistics of how long it takes tourists to die when they get lost, most of us would probably only last about 3 days. Okay, so much for the evidence. Now the fun begins. Now we turn to trying to explain the facts we found and assembled in our snapshots. So if you've been good little archaeologists, you've been taking notes, and in your notes is something more or less like this. Across the top row, we have a record of what kinds of stone tools, which of these different modes are present in the different samples. And in the rows along the side here are indications of which evidence of these different complex behaviors occur in the different samples, and our different snapshots of prehistory. There's two pretty clear patterns. The further back you go in time, the less and less variation there is in stone tool technology. Things drop out as you move further back in time. And the second pattern is that amongst the more recent time periods, there's greater evidence for complex behaviors. Evidence for stone tool use and behavioral complexity from 5,000 years ago and 30,000 years ago really don't differ all that much from one another. If you look at the specific differences, as I said, most of the differences reflect economics. The differences between people who have agriculture and pastoralism and live in permanent settlements, and the behavior of people who are mobile hunter-gatherers. The scale of these differences between 5,000 years ago and 30,000 years ago is comparable to the range of behavioral variability we see among living humans. Now, the evidence associated with earlier hominins in the 500,000-year-old sample and the 2-million-year-old sample, this evidence differs significantly from the 5,000-year and 30,000-year snapshots. Of the 5 stone tool modes, only 1 through 3 are represented, modes 1 through 3. Of the 9 complex behaviors, there's only evidence for one of them, fire, and this is only present in the 500,000-year-old sample. All known human societies make and use fire. No recent humans leave an archaeological record like the 500,000-year-old snapshot or the 2-million-year-old snapshot. What this suggests is that the behavior of the hominins, of the earlier hominins who created the record from these snapshots, was fundamentally different from that of the humans who lived in the more recent snapshots. Now, as I've said, this is the benefit of the comparative approach. It allows us to identify crucial intervals, not necessarily gaps, but rather crucial intervals in the archaeological record for human origins. Now, the first such gap or crucial interval is the one between 30,000 years ago and 500,000 years ago, during which distinctively human behavior appears. The second one is prior to 2 million years ago, during which distinctive hominin behavior appears. We're going to look at what archaeology can tell us about each of these important gaps in the record. Well, comparing early hominin and chimpanzee archaeological records can highlight some of the ways early hominins differed from other African apes. Chimpanzees use stone tools in the wild, and they can be taught to make stone tools in captivity. They do not make or use fire. Chimpanzees' stone tools are large stones transported short distances, less than 5 kilometers typically, and used without modification to crack nuts. Heavy objects and used to break nuts that allow the chimpanzees to eat the contents of the nuts. Stone tools made by early hominins are napped before use, transported greater distances, typically further than 10 kilometers, even amongst the oldest of these stone tools, and they feature sharp cutting edges. Now, nut-cracking stones improve access to food. Cutting edges enable their users to shape the world to suit their needs. There's a fundamental difference between those. I think we have a video to roll with this. Okay, what you're seeing is chimpanzee nut cracking, humans butchering. Now, there's a really important difference here as well. You'll notice this is a pedagogical exercise. I'm teaching these students how to butcher a goat. That chimpanzee behind, he could care less what the one in the front is doing. The baby's kind of paying attention, but that is not obviously watching what the parent is doing. He's playing with the products. That's a very fundamental difference. Humans learn in groups. Chimpanzees learn as individuals. Now, from 2.6 million years onwards, cut marks on the fossils of large animals show early hominins were using stone tools to get at meat and fat from the carcasses of those animals. Chimpanzees don't do this with their stone tools. Now, this difference could suggest that carnivory, or meat eating, was an important factor in the emergence of a distinctively hominin archaeological record. But the differences between chimpanzee and hominin stone tool use is not just about how the tools were used. Transporting stone tool use is another important difference. Because chimpanzees use their arms in locomotion, it's difficult for them to carry things, particularly heavy things, any great distances. Consequently, chimpanzees rarely move stones more than a few kilometers, and they use them only to crack nuts. For early hominins, who walked on 2 legs, carrying heavy stones would have been less difficult, which may have led them to carry stone tools more often, and to have taken advantage of opportunities to use stone tools in a wider range of contexts. In other words, early hominins' bipedality, they're walking on 2 legs, may have enabled them to become generalist tool users in contrast to our more specialist tool-using chimpanzee relatives. This is important. In evolution, generalists always beat specialists. So we're 7 billion, or however billion we are on this planet, and they're an endangered species. The archaeological record of recent humans differs from that of early hominins in its variability and in its complexity. Everything we humans do, we do in more than one identifiably different way, and often in circumstances that are identical. The Homo kibish humans, at the very origins of our species, are making stone tools in several clearly different ways, and these tools are all from the same level of the same archaeological site. In the early hominin archaeological record, in contrast, one finds more or less the same kinds of simple stone tools wherever hominins were living. If you chose to dig a hole in England in sediments that are 500,000 years old, you'll find these tools. If you dig that same hole in Libya, you'll find similar stone tools to these. If you dig that hole in India, you'll find these tools. If you keep digging holes all the way past the equator and on down to Cape Town, you'll find these same stone tools associated with these early hominins. If you do that same experiment in more recent time periods, you'll find categorically different kinds of tools spread out over different parts of the world. Chimpanzee stone tools track that less variable pattern. You've seen one chimpanzee stone tool, you've seen them all. When did this human capacity for behavioral variability and complexity evolve? This is a major issue in archaeology and possibly one of the most hotly contested issues in the archaeology of recent human evolution. And there are 3 main hypotheses about it. Some researchers argue that it evolved recently, and by implication that the earliest Homo sapiens did not possess the same capacity for behavioral variability and complexity that recent humans like ourselves do. Others see it emerging at about the same time as our species did, at around 200,000 years ago, but bear in mind that's just the oldest dated fossils we have so far. It's vanishingly improbable that the Homo kibish 1 fossil is the oldest Homo sapiens. As we obtain further evidence from Ethiopia and adjacent countries, the antiquity of our species is probably going to go back further and further. Now, still others, and I gotta tell you, myself included, see a capacity for behavioral variability and complexity as evolutionarily primitive. It may be a capacity Homo sapiens share with other hominin species who are now extinct, but one that simply appears distinctively human because Homo sapiens was the only hominin species to walk out of the Pleistocene Ice Ages alive. Archaeologists are pursuing two different strategies to winnow down these hypotheses. That's what you do in science. Arrange hypotheses and try to knock them down until there's only one last one standing. It's a very evolutionary process. The first strategy involves looking for behavioral variability and complexity in the archaeological record of early Homo sapiens. Early humans from Africa and Southwest Asia used mineral pigments, shell beads, and other complex artifacts, yet things we see everywhere amongst recent human hunter-gatherers, such as evidence for the use of bow and arrow or the domesticated dog, they're absent from Homo sapiens' early archaeological record. Does this mean there were evolutionary significant behavioral differences between early Homo sapiens and later ones? Well, if you're going to argue that, then you've got to argue there are evolutionary significant behavioral differences between those of you who own dogs and those of you who don't. How many of you guys own dogs? Okay. There you go. Rest of you guys, you're out of luck. Personally, I doubt there were such differences, but we need more evidence. Our conclusions have to be based on evidence, and we need more evidence from archaeological sites well dated, well documented from multiple locations in Africa and Asia. We can't just base our hypotheses on the evidence from one or two sites in Ethiopia. A second strategy involves looking for behavioral variability and complexity associated with extinct hominins such as the Neanderthals. Neanderthals lived in Europe and Western Asia between about 200,000 and about 30,000 years ago, as you heard earlier today. Now, excavations at Neanderthal sites like Kibara Cave in Israel, they show evidence for some fairly complex behaviors. The Kibara Neanderthals were building these fairly extensive hearths. They were attaching stone tools to handles. They were even burying their dead underneath some of these hearths. To evaluate the significance of this behavioral complexity we see at Kibara, it needs to be compared with evidence from our other archaeological sites. Now, this involves a bit of a thinking different about the archaeological record. We often throw a lot of resources at the record associated with hominins we think are ancestral. We need to throw just as many resources at the ones that are probably not ancestral. That's the only way you get a balanced picture. The only way you can evaluate the record of Neanderthals versus Homo sapiens is if you have equal quality data. The archaeological record is a rich source of information about human evolution. Archaeological sites outnumber human fossils for all but the earliest phases of prehistory. Now, it's important to remember that if you want to understand how people might have behaved in the past, you have to study how humans and other animals behave today. This is why archaeology is a constant dialogue between the past and the present. If any of you are thinking about a career in archaeology, I've just got a few remarks for you. Work as hard as you can, never quit, and I promise you, you'll have the adventure of a lifetime. Thank you. I will happily take some questions. This gentleman here.
Well, my question is, can you associate the type of stone tool with how complex the group of people was? Yeah.
Can you associate the complexity of the stone tool with the complexity of the people who made the stone tool? There you go. No. No. Complex people can make complex tools, but complex people can also make simple tools. You're a complex person, right? The tools you're going to make in about half an hour here are going to look just like those unearthed from the earliest archaeological sites in Ethiopia. That does not have any implication whatsoever about your complexity. I can effortlessly, I've been making stone tools since I was 11. I can effortlessly shift from any one of these different ways of making stone tools on a whim. Okay? Doesn't mean I'm complex. I am the simplest of simple guys. The link between complexity inferred from the archaeological record and the cognitive complexity of the authors, that's a very slippery one. I don't think any archaeologist feels one can confidently make a simple bridge from one to the other. Often, people who study stone tools will say, oh, that's a complex tool. Look at this thing. It must have taken you hours of study and years of tutorship. I made this in 15 minutes. It's not rocket science. Good. Got an answer? Who's got another question? In red here, yes.
What would be some of the indicators of controlled use of fire at a site that you would find? Okay,
controlled use of fire. Strongest evidence would be bones that have been charred, but exposed to the fire, and you can detect the changes in bone that occur as exposure to fire by comparing them to experimental replicas. Stones that are heated by fire repeatedly exhibit particular patterns of microscopic fracturing as well as oxidation of iron particles. There are, again, geophysical tests for this. There are paleomagnetic indicators of firing. There are many different ways of testing for fire. Right now, the oldest convincing evidence for me is about 800,000 years ago from the site of Gesher Benat Yaakov in Israel. Yes, in the back.
What caused early hominins to trend towards being carnivores compared to chimpanzees who were herbivores?
Chimpanzees aren't herbivores. They eat meat. I mean, they're the ones that Jane Goodall studies at Gombe are busy slaughtering the red colobus monkeys. Granted, much of this predation is by this one chimp, Frodo, who's the Rambo of chimps. But chimpanzees will eat meat. So it's not. So this is probably not a case of humans, taking a wide divergence from an ancestral, African ape path. It's rather them, pursuing a more specialized kind of way, a more generalized ancestral diet. They're emphasizing something in their ancestors' diet that the chimpanzees went off in a different direction. Yes?
Why do you think that people started using fire to heat their meat versus just eating raw meat? Because, it's extra effort and...
Well, exposing meat to fire makes it more easy to digest. It means you don't have to chew it as much. Have you ever tried to chew raw steak? Okay, it takes a lot of work. Chimpanzees spend a lot of their time chewing. Cooking meat makes it more easy to shear with your teeth, more easily metabolized. It's a way of improving the digestibility. Now, the really interesting thing is, how do they make that connection? How do they figure it out? Were they making fire, and did they find an animal carcass that had been burned by a range fire or something like this? We don't know that. We probably never will. But the pattern of association between fires and burnt animal bones is something we see from fairly early on, from that oldest archaeological site, but then with increasing frequency as we move into more recent time periods. Thank you.